Hello students, welcome back to Akshar ID classes, and I am your chemistry faculty S. Mohan. Students, in the last class we are discussing the topic called language of chemistry, and this consists of 12 synopsis, 12 parts, and in that we have successfully completed the 11 parts. Now today I am going to start with the 12th synopsis, that is from the language of chemistry. Alright friends. So in this chapter, in this synopsis, what are you going to discuss? We are going to discuss about the laws of combination. What are you going to discuss? Laws of combination. So it's a very important laws here. Right. So students, before going to the laws of combination, first let us see about the atom. So students, already since we are discussing that any matter is made up of a tiny particles called atoms, and this idea was there since BC onwards, even in India and other countries also like Greek. So Indian philosophers also knew that any matter is made up of a tiny particles before 2500 years back only. Okay, but the tiny particles in India, they were named as Paramanu. What they were named as? Paramanu. So any matter is made up of a tiny particles called Paramanus according to India. Right? Now, according to Greek philosophers, any matter is made up of a tiny particles which are called as atoms. So, in the Greek language, atom means indivisible, unbreakable, which we cannot break it. Clear to you? So, the idea of atoms is same even in India or Greek. Right. Now, based on this atom, the scientifically as a theory, first time it was given by the John Dalton, and it was known as Dalton's atomic theory. It's called as what? Dalton's atomic theory. Clear? And according to Dalton's atomic theory, the same points he said that any matter is made up of a tiny particles called atoms. And these atoms are invisible, means what? Which we cannot see. And indivisible, means what? They cannot be breakable. Right? And he also said that atoms of same element have the same properties, same mass, but atoms of the different elements have the different properties and different mass. And one more important point what he said is atoms combine in a fixed ratio to form a particular molecule. So these are the Dalton's atomic theory, and we discuss in the later classes. We have one more chapter called as atomic structure. In that we are going to discuss in detail about the Dalton's atomic theory. Right? So today we are going to discuss about the laws of chemical combination. What are you going to discuss? Laws of chemical combination. So here you students here, laws means what? Plural, not single, plural, right? Laws of chemical combination. So there are some laws which are combinedly called as laws of chemical combination. Okay. So what are those laws? Mainly the three laws are there. Okay. The first one is called the law of conservation of mass. So here the three laws are there. The first one is called the law of conservation of mass. Right. Second law is law of constant proportions. Okay. And third one is law of multiple proportions. Right. So these are the three laws, are combinedly called as laws of combination, chemical combination. Right. So here first law is called what? Law of conservation of mass. Second one is law of constant proportions, and third law is called law of multiple proportions. Now, let us see in detail, okay, one by one. The first one is law of chemical combination, law of conservation of mass. What law of chemical conservation of mass states? That mass can neither be created nor destroyed in chemical reactions. Very simple. The mass can neither be created nor destroyed in chemical reactions, right? The meaning is that, for example, the two elements are combining or two elements are reacting. Otherwise, let's see here, two elements or elements are combining and it's forming one product, right? So, the two elements which are reacting, they are called as the reactants. Already we studied in the last classes. In the balancing of equations, chemical reactions we have studied. So, the substances which are reacting, which are combining, they are called as the reactants. And after the chemical reaction, whatever the substances, new substances form, that is called as a product, right? So, law of conservation of mass, what it says is, the total mass of the reactants is equal to total mass of the product. This already we discussed, right? So, based on this law only, the equations can be balanced. Yes or no? That we discussed. Okay. Chalo, we see one example. For example, student here, for this one, I am going to give an example. I am taking calcium carbonate. Okay. I am taking what? Calcium carbonate. Right. And I am taking the calcium carbonate of 100 grams. How many grams? 100 grams. 100 grams of calcium carbonate I am taking. Now, I am heating this calcium carbonate. I am heating calcium carbonate. This already reaction we discussed in the previous classes, the decomposition reaction. On heating, it decomposes into calcium oxide and carbon dioxide. It decomposes into what? Calcium oxide and carbon dioxide, right? Now, if you see what is how much weight, how much mass of the calcium oxide is released, you know that calcium atomic mass, mass number 40, right? Oxygen 16. So, 40 plus 16, 56. So, here 56 grams of calcium oxide is formed here, and the carbon dioxide releasing, and carbon dioxide is 44 grams. You know, no? Like carbon atomic mass is 12 and oxygen 16, 16 to the 32 plus 12 is 44, right? So, here when you heat the 100 grams of calcium carbonate, it decomposes into 56 grams of calcium oxide and 44 grams of carbon dioxide, calcium oxide and carbon dioxide, right? Now, here this calcium carbonate is called reactant. Okay, on heating, the decomposition reaction is taking place and we are getting the calcium oxide and carbon dioxide. So, this is called products. These are called what? Products, right? Now, according to law of mass, law of conservation of mass, what it says, the total mass of the reactants should be equal to total mass of the product. Mass can neither be created nor destroyed during chemical reaction. So, here the mass of the reactant is 100. Now, mass of the product you see 56 plus 44, 100. So, the meaning is what? The mass in the reactants is equal to, the mass of the reactants is equal to mass of the products, right? So, this is called law of conservation of mass. That's all. Clear? Right now? Chalo, once again finally. So, law of conservation of mass, mass can neither be created nor destroyed in chemical reactions. The total mass of the reactants is equal to total mass of the product. This already we discussed. Chalo. Now, let us come to the law of constant proportions. Chalo. This is also important law. Law of constant proportions means what? One compound or one substance, we can say that, whatever the source may be, okay, one compound is obtained, for example, you think one compound is obtained from different sources, but still, the ratio of the masses of the elements in that compound remains constant. Constant means what? Same, remains constant. So, example I'll explain. For example, see students here, water. What is the formula of water? H2. Okay. So, now I am taking water. For this law, I am taking water. So, water formula is H2O. You know that, right? So here hydrogen and oxygen in the ratio of 2 is to 1, right? The mass of the hydrogen is what? 1. So 2 hydrogens are there. So in terms of mass, the 2 is to oxygen mass is 16. Okay, 16. Now 2 ones are 2 eights are. So the mass ratio in water, okay, of hydrogen oxygen is 1 is to 8. Clear? Now students, now imagine that here, for example, I am in Hyderabad, right? I am taking one water molecule from the Hyderabad, right? And today I am taking one water molecule and I will check the composition of water molecule, means the ratio of hydrogen and oxygen in that water molecule. So what I observe, the ratio of mass of hydrogen is 1 and oxygen is 8. So 1 is to 8 ratio. Now, for example, you think I am going to some other state. Okay, I'll go to some Uttar Pradesh, right? So there, Ganga river is there, right? So from that river, I'll take just one drop of water. And I'll see the mass ratio. You know that there also water only. Water is made up of H2O, 2 high. Okay, if I go to the Ganga and I take one water molecule, if I ask what is the water molecule formula, H2O. So that water is also made up of 2 hydrogen and oxygen. If I check the proportions, okay, mass ratios there, I'll get the same, right? 1 is to 8 only. Now, for example, I'm going to some other country, now other state, now other country. From there, I collect one water drop. And if I ask you what is the composition of water there, they are also same, that is H2O. The ratio of hydrogen and oxygen, mass ratio, is again there is 1 is to 8 only. So meaning is what? Here I am taking the water in Hyderabad, I am taking in other state like Uttar Pradesh, I am taking water molecule and in some other country. So wherever I see the mass ratio between hydrogen and oxygen remains constant, same. So that is called law of constant proportions. What it's called? Law of constant proportion. Did you understand the law of constant proportion? So law of constant proportion, what it states is a chemical compound. If we have a material, you can see the page number 99. A chemical compound always consists of the same elements combined together in the same proportions of mass, right? So whatever water, for example, I'm taking water, wherever you take the water, the composition remains same. The water is made up of 2 hydrogens and 1 oxygen and mass ratio is 1 is to 8. For example, if I take the carbon dioxide, right? So for example, you see students say carbon dioxide. Okay, here I discussed here. Carbon dioxide, here carbon dioxide, here I am preparing from by heating the calcium carbonate, right? So I got the carbon dioxide. You also know that carbon when burned in oxygen, that also gives the carbon dioxide. So here also I am getting the same carbon dioxide. We take some other reaction like for example sodium carbonate, okay, Na2CO3. When it reacts with the hydrochloric acid 2HCl, then it forms a product called NaCl plus H2O plus CO2. Okay, so here also carbon dioxide is formed. So let's see a balanced or not, 2 sodiums, 1 carbon, 3 oxygens. Here 1 plus 2, 3 oxygens, 2 hydrogens, 2 chlorines, 2 chlorines. Yes, it's balanced, right? So here also I'm getting the carbon dioxide. Here the way of preparation of carbon dioxide is different, right? So here by heating the calcium carbonate, I am getting the carbon dioxide. Here by burning the carbon, we are getting. So here by the action of hydrochloric acid on the sodium carbonate, I am getting the carbon dioxide. So here in the 3 cases I am getting the carbon dioxide, but way of preparation is different. No, this is another method, this is another method, this is another method, different compounds I am getting the carbon dioxide. But if I check the ratios of their masses, so carbon 1, 2 oxygens, right? So 2 oxygens. You know that carbon atomic mass is how much? 12, right? And oxygen atomic mass is how much? 16. 16 to the 32, right? Now if I cancel with 4, 4 3s are 4 8s are. So the ratio of carbon and oxygen, the carbon dioxide is 3 is to 8. How much it is? 3 is to 8. If I see here, here also the ratio should be 3 is to 8. Here also the ratio is 3 is to 8 only. So, whatever the method of preparation, whatever the source, the ratio of the masses of the elements present in that particular compound is always constant. Clear? So, this is called the law of constant proportions. Clear? Chalo. Now, let us see the last and final one. Last and final one is what? The law of multiple proportions. See students here, law of multiple proportions means what? One element can combine with other element in multiple ratios to form different compounds. Okay. So, did you understand? No. Okay. I'll explain it. Here also I can take the same example, but okay, no problem. So, for example, if you take the carbon, okay, and carbon we are making to react with the oxygen. Carbon we are making to react with the oxygen. So, here what happens? Carbon can react with the oxygen in two ways. How many ways? Two ways. Okay. One is carbon when react with oxygen, it forms carbon monoxide. What is called carbon monoxide. And carbon when burned in oxygen, it forms carbon dioxide. So, when carbon is burned in limited supply of oxygen, limited means what? Less. Limited means what? Less. Less amount of oxygen, it forms the carbon monoxide. When the carbon is burned in excess of oxygen, it reacts with excess of oxygen, it's more oxygen, then it forms a carbon dioxide, right? So, here the element wise, if you see, the ratio of carbon and oxygen is 1 is to 1, right? And here you see the ratio is between the carbon and oxygen is 1 is to 2. Is what? 1 is to 2. The meaning is what? Carbon is combining with oxygen not only in single way, in multiple ways. Okay, multiple means what? Many, 2 or more is called multiple. So, here what it states? Law of multiple proportions. Law of multiple proportions. The meaning is what? Two elements can combine in multiple proportions to form the simple compounds. Clear to you? So, this is known as a law of multiple proportions. For example, if you have a material, once you can see in the page number 100, law of multiple proportions, the weight of one element that separately combines, the weight of one element separately, combines with a fixed weight of another element, where a simple integral ratio is called the law of multiple proportions. Law of multiple proportions. Clear to you? So, carbon can react with the one, oxygen is the ratio of 1 is to 1 ratio, and it forms a carbon monoxide, and carbon can combine with the oxygen in the ratio of 1 is to 2 to form the carbon dioxide. Is this clear to you? So, students, this already we discussed, where I said you that us and ik, ferrous oxide, ferric oxide. So, here the ferrous oxide, ferric oxide, did you remember? I told you ferrous oxide, ferric oxide. So, in both the ferrous oxide and ferric oxide, the elements are same, like iron and oxygen. Ferrous oxide is also iron and oxygen, and ferric oxide is also iron and oxygen, right? But in the ferrous oxide, what's the formula? FeO. The ratio is 1 is to 1. And what's the formula of ferric oxide? Fe2O3. Okay, Fe2O3 means what? The ratio is 2 is to 3, right? So, two elements only, but they're in different proportions, right? So, that is called the law of multiple proportions. Clear to you? So, that's about the law of multiple proportions, right, students? So, similarly, in your material, it is given as example like a cupric oxide and a cuprous oxide. So, this also we discussed in the previous classes when you are differentiating between the us and the ik type of oxides, right? And then come to the calculation based on volume relationship. See, students, here calculations in the chemistry are based on different methods also, like mass relationship, mass volume relationship, volume volume relationship. So here calculations based on volume volume relationship, mass volume and mass mass. So different types of calculations are there, and these calculations let's discuss in the, we have another chapter called the states of matter, which is purely discuss about the calculation states of matter like solids, liquids and gases. So there we discuss about that volume volume relationship in detail, right? So students, here with this language of chemistry, the total chapter with the 12 synopses are done. Okay, so after this we'll have one test. Okay, at one we'll give a time to you when it is to be there, and at that time we conduct the test. Okay, meanwhile let us practice some questions here. So page number 103, concept based questions. According to Maharishi Kannada, matter is made up of small particles, and these particles are called, just now it will be Maharishi Kannada, who is a Indian philosopher. According to Indian philosophy, the particles are, any matter is made up of a tiny particles called what? Paramanu. As I told you, that is what? Paramanu. So what's the option here? Paramanu. Clear? Paramanu? Okay. Now, next one. All matter is made up of a small particles called. Okay. So any matter is made up of tiny particles called atoms. Okay. So that's the actual this one. But even you can say that both 1 and 2, because the molecules, oxygen for example, if you see, that exists in the form of a molecule. Okay, you can write answer 1 or 4, no problem. Matter can neither be created nor destroyed, but it undergoes physical and chemical changes, and this is called as what? Mass can neither be created nor destroyed. Okay, that comes under what? Law of conservation of mass. What it is? Law of conservation of mass. Clear? Next, calcium carbonate on heating, it gives calcium oxide plus X. Identify the product. So see here on the board itself, it is a calcium carbonate on heating, it decomposes into calcium oxide and X. What is X here? Carbon dioxide, right? So there is a carbon dioxide, right students? Next, in which ratio the carbon and oxygen, okay, in which ratio the carbon and oxygen combine to form a sample of carbon dioxide? So carbon dioxide, CO2, what the ratio I said? 3:8 or 12:32, whatever the answer is there. So 12:32, yes, that's correct. 4:32, 13 is to know. So here it is, carbon atomic mass is 12, oxygen 16, 16 to the 32. So the answer is 12:32 is also correct, or 3:8 is also correct, but here it is given 12:32. Okay, so that's the correct answer. Next, the weight of one element that separately combines with a fixed weight of another element where a simple integral ratio is called, just now I told you students, that is a law of multiple proportions. What is that? Law of multiple proportions. So the answer is what? Law of multiple proportions. The option is 3. Water molecules contains hydrogen 2 parts, oxygen 16 parts. No. Hydrogen 2 parts, oxygen 32 parts. Yeah, that's correct actually. Hydrogen 2 parts, which is the water molecule we discussed. Yeah. So hydrogen mass, according to mass is what? Hydrogen 2 parts and oxygen is 16. So the ratio is 2:16. So here the answer is first option, student. That is hydrogen 2 parts and oxygen 16 parts. And last and final one, nitrogen pentoxide, N2O5. O5 means what? Pent. I said, when you should add the pent when both are non-metals are there, right? So nitrogen pentoxide molecules contains. So see here now, nitrogen pentoxide molecules contains what you can write here? Nitrogen pentoxide N2O5. So here I am writing, can you see here? Right, okay. N2O5, right. So nitrogen atomic mass is 14 and 14 2s are 28 is to oxide atomic mass is 15, 15 6 are, sorry, oxide mass is 16, 16 5s are 18, okay. So the ratio is 28 is to 80. So the answer is what? Fourth option. Okay, 8th one is fourth option, that is 28 is to 80. Okay. So students, with this we completed the first complete chapter. It's a very lengthy, very important chapter for chemistry, that is language of chemistry with the 12 synopsis. And with this chapter is done. In the next class, we are going to discuss about we are going to start a new chapter, that is atomic structure. Atomic structure. So now, till now, you studied about the basics of chemistry. Okay, like basics of chemistry. What are atoms? What are elements? What is matter? What type of elements? How the elements can combine, and what is the molecular formula? What's the compounds, everything you learned. So what you have learned till now, what we discussed till now, if you are perfect in this topic, then the next remaining part of the chemistry becomes very easy to you. Okay, so with this we'll stop. Until, take care, bye.